As is often the case, I want to take it up a notch now. In this case, it's this particular problem says, what is the mass of glucose? So I'll put over here to the right, I'll put question mark grams of glucose. Okay, and there's the formula for glucose. We're going to need that. Is in 125 milliliters of this particular solution, and we have the molarity. 125 milliliters of solution. Now we've been using molarity to get from moles, we can get back and forth between moles of solute and liter of solution. So do you see where I can go from milliliters of solution to liters of solution? Of course, using something the relationship of 1,000 milliliters is equal to 1 liter of solution. And then do you see where I can go from liter of solution to moles of glucose? And I can do that using the molarity. Okay, that's our link between moles and liters of solution. And then how am I going to get from moles of glucose to grams of glucose? Using glucose's molar mass. So that's why actually we needed the formula, and we're going to use a periodic table to get the molar mass. Very good. So what did I say? Milliliter solution to liters of solution using 1,000 milliliters of solution equals 1 liter of solution. How are we going to get from liters of solution to moles? Using molarity. And then how are we going to get from moles to grams? Using molar mass. Sometimes students say, well, Mrs. Snipes, how did you know to do that? Those were the steps you need to use. Well, the more you do it, the more it will be like second nature, and you're going to have some practice doing that one with problems here in a minute. So what's the first term going to be? It's going to be the volume of solution. So remember, I would put that over 1. And what's the next term going to be? We want milliliters to cancel, be left with liters of solution, so it looks like this. 1 liter of solution over 1,000 milliliters of solution. Now we're ready to use molarity, and I didn't unpack it for you, but hopefully you can look back at what the problem says. So what does the third term look like? We want liters of solution to cancel, be left with moles of glucose. It looks like this. 0.432 moles of C6H12O6 over 1 liter of solution. At this point, if you're canceling things, well, we got milliliters to cancel, we have liters to cancel, we're left with units of moles, but we want grams. So, did I ever come up with the molar mass of glucose? Maybe I did it earlier. Now we're going to use the molar mass of glucose. I don't remember doing that though. You'd have to show me calculating the molar mass of glucose. Molar mass of glucose using the periodic table is 180.6 grams per mole, so we're going to use it this way so that units of moles cancel and we're left with units of grams, which is exactly where we want to be. How many sig figs are we allowed in our answer here? 3, because I got 3 sig figs here. There's no uncertainty introduced here. There is uncertainty in the molarity, and there actually is uncertainty in the molar mass, but we have 5 here. So 3, 3, and 5, I'm liking 3. All right, so did you get this? 9.73 grams of glucose. So, I mean, this could be a practical thing. If you know that you want 125 milliliters of this molar glucose solution, this is the mass of glucose you need to dissolve in 125 milliliters. All right, so, yep, bumping up against an assignment slide, just checking. So be sure to show all your work. If you need a molar mass, you be sure to show how you calculate a molar mass using the periodic table. And round correctly, make sure that you include all appropriate units.